Okay, so here's another example. This is a quadratic function. F of x is equal to negative 3x squared plus 24x minus 31. So let's run through some of these. We may not do them in the regular order. We know that the lead coefficient is negative 3. That's our a. In fact, let's go ahead and make a note on the side here. A is equal to negative 3, B is equal to 24, and C is equal to negative 31. Well, we know the C is the constant term. So the constant term C is negative 31. We know that in a polynomial, the constant term is the same as f of 0, so that's negative 31. We also know that the rate of change is variable and that we're not going to do that in a college algebra class. You can wait for calculus to do that. And we know that the domain of a polynomial function is negative infinity to positive infinity. Okay? All right, so that's the easy stuff. Now let's get to the stuff that requires a little bit of work. Okay? Let's go ahead and identify our critical x value. We know that our critical x value is found by doing negative b over 2a. In this case, b is 24, so we're going to do negative 24 over 2 times negative 3. That gives us negative 24 over 2 times negative 3 is negative 6. Negative divided by negative is a positive, and 24 divided by 6 is 4. And therefore, our critical x is x equals 4. Now, we can go ahead and find the roots. Well, I've got bad news for you. In this particular case, this is not factorable. I already know that in advance. But even if it was factorable, this negative 3 is a little intimidating. So I think I'd probably go ahead with the quadratic formula. So quadratic formula, x is equal to negative b. So that's negative. B is 24 in this case, so it's negative 24 plus or minus the square root of b squared, that's 24 squared, minus 4 times a, in this case negative 3, times c, negative 31. I'm feeling a calculator coming along. That's a lot of bigger than usual numbers, okay? All over 2a, that's 2 times negative 3, okay? So let's go ahead and do this. X is equal to, well, negative 24 is negative 24. Plus or minus. I'm going to grab a calculator for this one. I actually don't have one nearby, but I do have my cell phone, and that has a nice NumWorks calculator app on it. Highly recommend the NumWorks graphing calculator. I also recommend the other ones, but I happen to love the NumWorks. All right, so we're going to have 24 squared minus 4 times a, which is negative 3, times negative 31. And so when we hit that, we get 204. So we're going to have the square root of 204 over 2 times negative 3 is negative 6. Now, I want to show you something here. I want you to notice that this is negative and this is negative. And so we have a negative divided by a negative, and so they can cancel each other out. Okay, so we're going to cancel off those negatives. You may say, well, does it have to distribute here? No, remember, we're doing one of each, plus or minus. So the plus will become minus, the minus will become plus, and it'll be the same, okay? So we've got x is equal to 24 plus the square root of 204 over 6, and x is equal to 24 minus the square root of 204 divided by 6, okay? And so now these are actually our zeros. Now this could become a little confusing when it comes time to do our sign chart, but for now let's go with what we have. X is equal to 24 plus the square root of 204 over 6, and x is equal to 24 minus the square root of 204 over 6, okay? All right, so we've got our roots of this function. Now let's go ahead and identify our sign chart. So we know in our sign chart we're going to have infinity on the right, negative infinity on the left. We've got 2 zeros, so we're going to put 2 hash marks. Now, we don't know for sure which one of these is a larger or smaller number. Now I do, because look, we're going to take 24 and then add a positive number to it, then divide by 6. Here we're going to take 24 and subtract a positive number from it and divide by 6. This one is smaller. So we're going to put 24 minus the square root of 204 over 6 here. Then over here we'll put 24 plus the square root of 204 divided by 6. Now I want to remind you that halfway between these two numbers is our critical x. So we know that somewhere in here in between is a 4. And that means that this number is larger than 4 and this number is smaller than 4. Okay? So what we can do is, I told you this before, we can take the 4, we can use the critical x to find our middle term as positive or negative. So let's go ahead and plug 4 into our function. Remember, we're going to need that later anyways when we do our range, okay? So it's a good idea to go ahead and find out what is f of our critical x, okay? So we'll have negative 3 times 4 squared plus 24 times 4 minus 31. And that's going to be, so 4 squared, that's 16. 16 times negative 3, that's negative 48. 24 times 4, that's 96, so plus 96, and then minus 31. Now I want to point something out to you. I don't know if you'll notice this pattern, but I've done so many of these. Do you see this right here? This happens every single time with your critical f value, okay? We've got negative 48 plus 96 happens to be double 48, and negative 48 plus 96 is positive 48. And so what we're going to wind up with is positive 48 minus 31, which is 17. And so f of 4 is equal to 17. So let's remember that over here when we do the range, that f of 4 is equal to 17. That'll also come in handy when we do our intervals of increase and decrease, okay? But what that means is that in between here and here, all the output values are positive. And as far as the way quadratics typically go is if there are two zeros. If there's only one zero, then you can't count on what I'm about to say. But if there are exactly two zeros, then the other two signs are negative. Let's prove it. Let's take a reasonably large number that we're pretty sure is larger than this. Let's take a number like 100, okay? So negative 3 times 100 squared plus 24 times 100 minus 31 gives us negative 27,631. So sure enough, negative. Okay, we could do the same thing over here. We could do something like negative 100. So we could take that same thing, but put in a negative for it. Put a negative in for the 100. And sure enough, negative 32,000. So those are negative. So we've got a correct sign chart here. And now let's jump down to, let's go ahead and jump down. We'll do the intervals of increase and decrease in a second. Let's do the limits as x approaches negative infinity and the limit as x approaches positive infinity. What happens to f of x when x is near negative infinity? Well, here's negative infinity, so x is near negative infinity, and the f of x values are negative, and therefore negative infinity. What about when x is near positive infinity? Well, here's positive infinity. When x is near positive infinity, the f of x values are negative, therefore negative infinity, okay? All right, so let's go to the intervals of increase and decrease. So what I've just done is I have identified f of 4, which we need. So we know that the interval of increase is going to look something like this, and the interval of decrease is going to look something like this, okay? And here's what you need to understand. So with these limits, here's another way of doing it. Do you see these limits as x approaches infinity? We know that negative infinity is near negative infinity, and then it goes up to positive, and then from positive goes down to negatives as we approach positive infinity. What that indicates is that we go from smaller numbers to larger numbers back down to smaller numbers. That's what this sign chart means. that we start at negative numbers, we go up to positive numbers, and then we go down to negative numbers. And that must mean that if we're going from negative up to positive, then we're increasing. And if we're going from positive down to negative, that must mean we're decreasing. And so the interval of increase is going to start over here at negative infinity, and then it's going to end at 4. It's going to end at the critical x. And the interval of decrease is going to start at 4, and it's going to end at a negative number. And so that is also, sorry, let me rephrase. Sorry, we're not going to put negative infinity here. These are x values here. So we're going from negative infinity here, this negative infinity, not that one. X is negative infinity up to 4, and then from 4 up to infinity, the quadratic is decreasing, okay? And so now we've got our intervals of increase and decrease. The only thing we have left to do is the range. The range is, remember we said that if both of these are negative, then that's going to be our minimum value, okay? So for this one, we know we're going to have negative infinity, and then our highest value, our maximum value, is going to come from our f of 4, which is 17. And so our range runs from negative infinity up to 17, which is consistent with our sign chart. We start at negative values, we go up to positive values, 17 is the highest, then we go back to negative values. And so all of our values, none of this will never equal 18 or 19 or 20 because the highest possible value is 17. Now, you may have to watch everything I just did to understand this. You may have to watch it 2 or 3 times, but I promise you by the 3rd or 4th time that you watch this, it'll sink in. And you really need to be paying attention. Don't be doing something else on your phone or you're going to lose attention. You're going to miss all of the connections, okay? Let's do another example. All right, this will be our last example. Here we have a quadratic function. F of x is equal to negative x squared minus 2x plus 24. So let's go ahead and identify our a, b, and c. A is negative 1, b is negative 2, and c is positive 24. And so our lead coefficient a is negative 1. Our constant term c is equal to 24, which means our f of 0 is also 24. We know that our rate of change is variable, so we're going to wait for calculus. And so and our domain is going to be negative infinity to positive infinity, okay? All right, so let's go ahead and identify our critical x up there. We know the critical x is going to be negative b over 2a. Negative b here, b is negative 2. So that's negative 2 over 2 times a, and a is negative 1. Well, negative 2, that's 2. 2 times negative 1, that's negative 2. And 2 divided by negative 2 equals negative 1. And so our critical x value is negative 1. X equals negative 1. Now we know we're going to need f of negative 1, so we may as well go ahead and get that right now. F of negative 1 is going to be, we're going to do negative, plug in negative 1 for x, square it, minus 2 times negative 1 plus 24. Okay, this could get a little crazy. There's a lot of negatives here, okay? All right, negative 1 squared, that's 1. So we have negative 1. Negative 2 times negative 1, that's positive 2. And then plus 24. And so what we wind up with is negative 1 plus 2, that's 1, plus 24, that's 25. And so f of negative 1 is equal to 25. That could be, well, will be, f of negative 1 is 25. That's going to be useful when we do the range and probably some of the other things that we do, okay? All right, what about the roots, okay? Well, we know to find the roots, we're going to set our function, or our expression, we're going to set it equal to 0. We're going to make y equals 0, and then negative x squared minus 2x plus 24. Well, look at this. Remember how we said when we were going to solve a quadratic, we set it equal to 0, but we would really like for the lead coefficient to actually be positive instead of negative. So what I'm going to do is I'm actually going to move all of this over here. I'm going to add x squared, I'm going to add 2x, I'm going to add 2x, and I'm going to subtract 24, okay? So that's going to actually eliminate this whole side, and I'm going to have 0 on the right side instead of the left. But over here now I have x squared, positive x squared, plus 2x minus 24. And now this is factorable, okay? Factorable, so if I, what two numbers? Well, we know that it's going to become x here and x here. Two numbers that multiply to negative 24, but add up to positive 2 are positive 6 and negative 4 equals 0. Now we're going to set each of these separately equal to 0. X minus 4 equals 0. The solution here is going to be x equals negative 6. The solution here is going to be x is equal to 4. And so our roots are x equals negative 6 and x equals 4. Okay. All right, we've got our roots. Now we're going to make our sign chart. Our sign chart is going to be a horizontal line with a positive infinity over here, a negative infinity over here. We have two roots. Put a hash mark here, hash mark here. Negative 6 is less than 4, so we'll put negative 6 here, and we'll put 4 here. Now, this critical x, negative 1, we know that it's halfway between these two. It's at negative 1. Negative 1 is 5 larger than negative 6 and 5 smaller than 4. So I'm just sort of proving to you. Now look, where our negative 1 is, we know that negative 1 is on this interval, and we already know that f of negative 1 is equal to positive 25. And that means the middle here has all positive output values. Okay? And you can plug in anything that's between negative 6 and 4, and you will see that the answer is going to be a positive number. Which probably means we're going to have a negative here and a negative here, but let's make sure, okay? Let's take, over here, let's take 5. Let's plug 5 in, okay? 5 squared is 25, but we're doing the negative of it. That's negative 25. 2 times 5 is 10, but we're subtracting it, minus 10. Then plus 24. Well, negative 25 minus 10 is negative 35, plus 24, that's negative 11, and so negative value, okay? We can do the same thing over here, let's say with negative 10. Negative 10 squared, negative 10 times negative 10 is 100, but we're doing the negative of it, so it's negative 100. Minus 2 times negative 10 is negative 20. That makes this plus 20, okay? And then plus 24. So negative 100 plus 20 is negative 80. Negative 80 plus 24 is negative 56, but it's still a negative number, and therefore we have a correct sign chart. Okay? Already got the constant term, rate of change. All right, let's talk about these intervals of increase and decrease. You know, we're going to skip that. We're going to go down to the limits at infinity. As x approaches negative infinity, we can go to our sign chart. Where is f of x? Well, this sign chart says that next to negative infinity, all the values are negative, and that means negative infinity. Okay? Let's go to positive infinity, where x is positive. Here's x is positive infinity. Well, all the y values are negative next to that, so this is also negative infinity. And so now what we can see is happening with our intervals of increase and decrease, okay, is at negative infinity, we are near negative infinity. Our output values are at negative infinity. So they're going from negative infinity up to positive. And we know that the positive that they go up to is 25 because f of negative 1 is equal to 25. So we're going from negative numbers up to 25, then from 25 down to negative numbers, okay? So that means we're increasing. This region is an interval of increase, and then we're going from positive 25 down to negative numbers. So that's an interval of decrease, okay? So our interval of increase is starting here and going up to -1. So negative infinity up to -1. Our interval of decrease is starting at -1 and going up to infinity. -1 up to infinity, and therefore now we have our intervals of increase and decrease. Remember that quadratic functions do not have a constant interval, okay? Almost done. Last part, range. We just need the minimum value and the maximum value. Well, we know that the values can go down as far as -infinity. So we know that the minimum is going to be -infinity, which is actually no minimum at all. It means that there is no minimum. And then the maximum value, the highest that we ever go, is wherever our critical x is, f of -1, and the output value is 25. So the highest possible value for this function is 25, and we're done, okay? I highly recommend that you do every single problem that I give you. It'll probably be about 6 or 8 of them so that you can get this procedure in your mind so that it's really easy for you to identify all these qualities of a quadratic function, okay? Well, I hope you have a great day, and I'll see you later.